Hello, students. Welcome to today's session on work, energy, and power from the unit Work, Energy, and Power, a very crucial unit from examination point of view, each competitive and board level game. So, yeah, when we first consider, let us define the quantity work. So, what do you mean by work? Work in physics is said to be done when force and displacement are acting together. That means a force acts upon a body and it displaces from a certain position, position x is equals to 0 to position x is equals to x dash. Okay. So there is a displacement seen and a force or an external agency is getting applied, due to which the force is caused. And the dot product of it is giving you work. As we can witness the formula on the screen, that's what physically quantizing the work means. That's close integration of F dot ds, where force and displacement are the vectors. And as we can see that the close integration of force and displacement is giving you work. Next, work done by the force, it depends upon the reference frame. Yes, it depends. Like if we are applying force in the XY, X axis and Y axis, namely, the work will be done in the XY plane itself. The plane which is into consideration with respect to X and Y is the XY plane, and if the body is moving and the force is also acting upon the XY plane or the 2D plane, then the work is also said to be applied in the particular 2D plane. Yeah. Then work is done by a constant force, the first factor. Constant force means the force will be constant over a period of time. That means you can say like for time t is equal to 0 to time t is equal to 5 seconds, we can see that the force is acting to be incomplete and in completion. So the work done shall be calculated on spur of that constant force. Secondly, the work done by variable force. Now, for variable force, if we consider what is the variable force? Variable force means it was varying from time t is equal to 0 to time t is equal to 5 seconds. But the time may or may not be constant, and it changes also instantaneously. It's known as work instantaneous. And then you have the third category to be work done by the tangential force, where the work will be acting upon the direction of that particular, like if this is the body, and if we try drawing a tangent which is a perpendicular line, so the work done by this tangential force, now force was acting as in terms of tangent, means it was acting along conveying the direction, and the work done is giving you the tangential force, or the work done which is calculated by the tangential force. So these are the four categories. And then you have the work done which are central force, centrally mediated force. If it is there in the scene, then the work done by it is calculated into some other dynamics. So there are four different categories. First is the work done by constant force. Second, work done by variable force. Third, work done by tangential force. And the fourth one is the work done by central force. Let us look upon one of the examples, and we'll be solving the example right upon. If force F is equals to x square I cap plus y square j cap times Newton, that means the unit is Newton, it is acting on a particle and a particle is moving from 0, 1 to 1, 2. We need to find and calculate the work. Now for this work to be calculated, as you can see, the force is plying into two components, that is x and then is y. So you need to quantize it or break it into two components. which will be fx dx plus integration of fy dy. Substituting the values. X square, I substituted the x square in it, in the formula of force, and for Fy, we will be substituting y square. Dy. And causing an integration from the limit where the lower limit is 1 and the upper limit is x. And this, when calculated, turns out to be x square. The integration of x square is x cubed by 3 plus y cubed by 3 for the next variable. The answer turns out to be upper limit minus lower limit. We have just substituted the values. And yes, that's our answer, 8 by 3. And the unit, SI unit of work is Joule. Like this, we'll be considering many other numericals in my upcoming session. There are certain cases which has been discussed of the position of a spring and the cases when the spring you can turn out to be a natural spring elongated and a compressed spring. So when a natural spring, we have a natural spring and then we have an elongated spring and then a compressed spring. What are the changes in terms of work? So for a natural spring, we have minus half kx square. That's the affinity. And that means that what does the minus direction denotes? Minus sign actually denotes the direction of that work which has been into the scene. Because when you're compressing it, upon compressing, okay, final state of the spring is the compressed one. The spring will not stay like that. When you release it or when you leave it, the spring will cause the actual release. And so it's acting in the negative direction. The work is acting in the negative direction of the commenced force. So that's why the term minus half x square, half kx square, where k is the spring constant. In the initial state of the spring, we have elongated final state where we have the elongated spring. In that case also, because of the changes in positions, which is x1 to x2, the vice versa, which is from 0 to x, we are having minus half kx square as the final work. And from elongated state to the natural spring, we have positive work because it's just the vice versa of what was done in the second case. The third case is the vice versa of the second case. Likewise, we have two more cases where we have elongated, compressed, and compressed and elongated cases. Yeah. And so these will be the work. And when you have an elongated spring and the final state of the spring is compressed, x1 keeping it to be x and x2 keeping it to be minus x, the work done turns out to be 0. And in the compressed state, where initial state of the spring is compressed and the final state of the spring is elongated, the two states when we are considering of the positions of the spring, when we are considering minus x and x, the work turns out to be 0 again. So it all depends upon the perspective. It's a very distance displacement kind of a concept where it is a relative quantity basically. This thing, this the compression and the elongation. What is elongation for one could be compression for the other. But you need to keep your sign conventions fixed. This is what we'll be considering in our upcoming classes. One more entity of this dynamic is power. And what is power? Power is defined as the rate of doing work of capacity. Whose capacity is what? Like if there are two bodies performing the same work, who is more efficient is what you can terminalize as power. Okay. And when you're dividing work by power, by rate, sorry, you are getting the next entity, which is power. The amount of energy which is transferred or converted per unit time. The energy could be either absorbed or released, but per unit time is what you are calling for power. Exactly. So there has been given one example where there is a change in potential energy to the kinetic energy, the energy which is the next concept will be discussed in my upcoming classes. Yes. So there is a mass which is kept at a height h, and the same mass is again kept at a height h, but there are two cases considered. Why? Because the time which is taken in the first case is t1 and the second case is t2. So when t2 is greater than t1, what is the change in terms of work performed, or what is the change in terms of the energy? It's a very obvious fact that the case in which the time has been less, power can be considered to be more. Okay. And the case in which we are considering the time to be more, power could be less. Likewise, the same mass, but the changes in terms of or in context of time, keeping all other quantities as constant. So instantaneous power means when we are calling power and uh, instantaneous power and average power, we all know this. This is now the uh, sequence of each and every quantity we are discussing. So we are discussing power instantaneous earlier. Then this we have discussed acceleration instantaneous and then average acceleration. So instantaneous power and instantaneous and power average power is what is meant by them respectively. When we are calling for time t is equal to 1, time t is equal to 2, time t is equal to 3. Okay, on that particular instant, the power which the body possesses is known as the instantaneous power. Whereas for the average power, we have a time span, like from 0 to time is equals to 3. The power measured is known as the average power. And that's what you can see in the formula. That's the sign of average is equals to total work done upon total time taken to do that work. Whereas it is the differentiation of work in terms of instantaneous power, it is dW by dt. SI unit is joule per second, which is measured in watt, and 1 horsepower is equal to 746 watts, is what you can see on screen. These are certain scientific units which one needs to grab for acing the boards, also the competitive grades. Yeah. I hope you all understood the topic, students. Keep practicing, and I'll see you in my upcoming sessions. If you have any doubts, please contact my Urban Pro profile. Thank you so much.